Hello everyone, welcome back. In this video, we will be attempting various quiz questions to prepare you for the upcoming Biodiesel tournament on 26th June from 6 p.m. to 7:30 p.m. This tournament is exclusively for school students, and this is your chance to win exciting prizes and goodies. So basically, in this tournament, you need to, participate in 20 MCQ questions that hold 100 marks in total and two coding questions, 100 marks each. And the total duration for this test would be 90 minutes. So make sure that you register for it and do not miss out this amazing opportunity. Now let's start with today's session. So the first question is, what is the time complexity of searching for an element in a circular linked list? Okay. So guys, basically for solving this question, first thing is that you need to know what is circular linked list. So let's start from there. So basically a circular linked list is, this is a starting node, this is an intermediate node, this is intermediate node, and finally we have the last node, right? So basically all the nodes are connected with each other, and even the last node and the first node are connected with each other. So it forms a kind of circle. Now this is known as a circular linked list. Now I need to find out the time complexity for searching an element in this kind of a list, right? So the time complexity for searching an element over here is big O of n. Why big O of n? Because see, everything is already connected, right? So it is very easy for you to search an element. So the time complexity for this is big O of n, that is option number A. Okay. So I hope this is clear to you. So now let's move forward to the next question. 1 minute. Okay. Next question is, which of the following sorting algorithms provide the best time complexity in the worst case scenario? Okay. You are given different sorting algorithms and you need to tell which of them provides the best, best time complexity in the worst situation. First, let us note down what can be the worst situations. First, second, third. First is whatever you are searching for is not present. Okay, like it is not in the list. Okay. Next is that it is way too big. The array is way too big, the linked list is way too big, and it is difficult for you to search it. So size. Third is that the element that you're trying to search is the last one. Okay, so last. Now these are some of the worst case scenarios while you are trying to search for an element. Okay. Now basically you would get stuck in two options. First it's merge sort, and second is quick sort. Now basically both the options are quite close, but one point that makes merge sort the answer is that merge sort gives better time complexity for larger data elements. So when you have a bigger size array or bigger size linked list, so it's better to do merge sort while you are searching for something, because the time complexity is better over here compared to quick sort, and other than that it works better with large data elements. Okay, so that's why the correct answer is merge sort. Now let's move forward. This is the next question. Question is, let P be a singly linked list. Let Q be the pointer to an intermediate node X in the list. Okay. The question is not completed. What is the worst case time complexity? Worst case time complexity of the best known algorithm to delete the node Q from the list. So you need to tell what can be the worst time complexity for the best, algorithm that you can apply on. So basically, if you want to delete something, what you can do is, for example, you want to delete the last somewhere a node that is quite close to the end, and you are at the intermediate node right now. So what you can do is you can copy the data from here and paste it here. Now basically you are already in the intermediate area, right? And you have already copied the data that needs to be deleted. So what you can do is you can directly just delete the intermediate node, right? You would not need to, go beyond that point. So it's better, rather than traversing till the position where you would find the one that you need to delete, why not just copy its data, paste it in another node, intermediate node, and delete that particular node. So this is the best algorithm for this. This is the best algorithm, and the best algorithm would give the time complexity big O of 1. Okay, so the correct answer is this. So I hope you are clear with the concept, and now let's move forward. One moment. Next question. Elements in an array are accessed. Okay, how can you access the elements of an array? Okay, options are randomly, sequentially, exponentially, and last is logarithmically. So basically, let's take an array. You have an array 10, 20, 30, 40, and 50. Okay, let's even write the index positions. Now basically, if I want to access element number 40, so basically what I have to do is I can directly access it using the index position, right? I can directly use its index position to access that element, right? So this is so easy. I do not have to follow a sequence. I don't need to start from the end or from the start and reach that particular element. I can just randomly use the index position and randomly access the element that I want. So the correct answer for this question will be random. Okay, so I hope you are clear with the concept. Now let's move forward. Okay, next question is, what is the information which a linked list node must store? Okay, what kind of information a linked list node must store? First, the address of the next node if it exists. Second option is the value of the current node. Third option is both A and B. And fourth option is none of the above. Let's understand it. This is a linked node. Okay, basically it has two parts. First is the value of this particular node, and second one is pointer to the next node. So basically pointer can be the address slash location for the next node. Okay, so next. So basically it has both. It has the address for the next node as well as it has the value for that particular node. So it has both. Option number A and B both are present. So that is why the correct option is C. Now these kind of questions are very easily solvable if you are clear with the concept. Okay, if you know what is linked list, just the definition, and you are clear how they work, you can easily answer these questions. Okay, so make sure that you are clear with the basic concepts. Now let's move forward. Next question. Which of the following represent the post order traversal of a binary tree? Now basically we are only asked for the post order traversal, but I would tell you the pre-order and in order as well. So let's start. Pre-order, in order, and post order. Okay, let's see. So post order is left, right, and then root. Okay, now in order is left, root, and right. And finally the pre-order is root, left, right. Okay, so this is the order. Okay, so basically you just need to know about the post order one for this question. But for your information, I have told you about all the others as well. Okay, so basically the post order is left, right, and root. So the correct answer for this is option number A. So I hope you guys are clear with this question. So now let's move forward. Okay, 1 minute. Okay, now this is the next question. Which of the following data structure can't store the non-homogeneous data elements? Okay, so basically before solving this question, you need to understand the meaning of non-homogeneous. Non-homogeneous means mixed data type. By mixed data type, I mean that in the same data structure you are storing integers with string values, okay? Or maybe you are storing integers and float values together. So you are mixing data types and storing them together in a single data structure. So that is what I mean by non-homogeneous. So you need to tell which of them does not support. Now among the options, array is the one that stores only homogeneous data. Okay? By homogeneous data, I mean it stores uniform data. If you are making an array of integers, then it can only store integer values. Okay, so that is why the correct answer for this question is array. Okay, so I hope you guys are clear with it. So let's move forward. 1 minute. Okay. Next question. The elements of a linked list are stored. Okay, where do you store the elements of a linked list? Options are in a structure, in an array, in contiguous memory locations. Any with the computer has space for them. Okay. Now the correct answer for this is anywhere the computer has space for them. Okay. So I hope you guys are clear with this question. Again, if you are clear with the concept of the data structure, if you are clear and you are clear with the working, then you can easily solve this questions. Now let's move forward. Next question is, before deletion condition of a stack, one must check for the following condition. Okay, let's see what it means. Basically, you have a stack and you want to delete something, that means pop something. Now, if you want to pop/delete something, first you need to check if there is something that you can delete or not, right? If something is already empty, you cannot delete anything because nothing is left. So you need to check if empty or not. And this condition has a name, that is underflow. Okay, so the correct answer for this question would be B. Now when I am telling you about underflow, I would also tell you about overflow. Basically, when you are trying to add an element in a stack, you need to check if the stack is full or not. Because if the stack is already full, you cannot add more elements in it, right? So, if full or not, right? So, this condition is known as overflow. So, I hope you guys are clear with this. Underflow, when you are checking it is empty or not. Overflow is checking if full or not, okay? And the correct answer for this question would be underflow. Okay, that is option number B. Now let's move forward. Okay, next question is here. How many modifications of pointers are required for insertion of an element at the end of a linked list? Okay, you are trying to add an element at the end of the linked list. How many modifications are required? Now see, basically this is a linked list. Start, intermediate, last. And you are trying to add a new element here, right? When you are trying to add a new element here, see it's already the end, right? You don't need to modify anything much. You just need to add one element in the end. So the number of modifications for this would be 1. You just need to add an element in the end, right? You don't need to modify anything else. So the correct answer for this is option number A. So I hope you guys are clear with it. So now let's move forward. 1 minute. Okay. So guys, I hope this session was helpful for you and you got to learn something from it. If you guys have enjoyed the session, make sure you click on the like button and subscribe our channel. And guys, make sure that you register for BioVisit Tournament 4.0 that is going to be conducted on 26 June, 6 p.m. to 7:30 p.m. and do not miss out this chance to win exciting prizes. And thank you for joining me today. Thank you.